And yeah, small teams develop them. If you're wondering, services are different from microservices, only with the word micro. Actually, it's kind of the same thing. So yeah, and basically, usually services are done in an agile way. So like you have a small team, the developers are interchangeable, and yeah, well, like they do everything, and yeah, they're fast. They deploy every day 2 or 3 times, maybe 10. Yeah, and have fun with that. But actually, come to think of it, when the service architecture starts, like when you develop in a project, it's not actually, like, it doesn't start from services. It starts with a monolith, usually. And, well, it would be a good thing to know first what a monolith is. That's actually from Wikipedia. I love the resource. Yeah, and when you dig into the concept, it turns out that monolith applications actually are not about services at all. So if you like have a server, a node, and like one database, it's not necessarily a monolithic application, because monolithic concept is actually about modularity. So like you can have one server, one database, and it still won't be a monolithic application. But an important thing is that there's like the other part, the services, and for services it's quite the same. So you can like have multiple services, they communicate between each other, and they could be monolithic if you haven't done the isolation part right, and there is no modularity. Yeah, and actually about data warehousing, the best thing for a data warehouse, a classical one, like with the ETL processes, all the integrations, it's a monolithic application. Because like the main purpose of the classical data warehouse is to make a concept of a business with data. And when you have a monolithic application that gives you the data, it's all connected anyway already. So it's like integrate, make some reports, be happy. Yeah, a brief history of data and warehousing. Just a quick question. Who of you have done some data warehousing, I mean modeling, created, yeah, ETL processes, integrations? Oh, nice. Experienced audience. Thank you. So, yeah, the history is actually quite fun. In the 60s, around 60s, people did files. They like used files. Files were the data were files. Users had access to files, and in files were the reports. And well, actually, they printed them to paper on files, from files to paper. Yeah, and then relational databases came in around 70s, 80s, and it was like awesome. You could give access to users, so they could like watch the data with SQL or other stuff. Yeah, there was process management, so multiple users could like edit and work with data, and it was awesome. And yeah, that brought relations. So yay for modularity and decoupling with joins. Okay, next one were data warehouses. That's actually like when relational database come in, there are applications which use them, of course, and first they used them and it was like okay, but then the performance problems began and they like figure out the replication, and like users had access to replication. That's like logical thing, and then they brought conceptuality to it. Like they figure out okay, we can like access the data, we don't ruin the application performance, but now we like want to I don't know, maybe clean something, maybe like change something, make it more business-like. So yeah, data warehouses came in. It became more conceptually solid. There were facts and dimensions and all that stuff. Yeah, people became doing advanced ETL and more importantly, data cleansing. And yeah, the last thing, but not the least, big data. Yay. Increased data volumes, very hard to work with them. That's basically when distributed data warehouse began, like Hadoop, a distributed system, and yeah, other stuff based on it. But actually, it was and still is the main problem is the ETL part, like interpreting data, making the reports. It requires human resources. And here's like a very simple, like, why is that? Why do we need ETL? Why do you need to make reports? Like, we have the data. What's the problem? Yeah, and the problem actually is how like we do applications, because like a software application is actually a very non-physical thing. Like, you have business processes in real life which are separate, and you have an application which does something, like imitates the business processes, but they don't always are the same. Like, for example, a typical developer sits, programs something, and the business users comes in and says, oh, okay, I have a button, it does A, and I want it to do B. And developer says, yeah, sure, boss, I'll just change it. Yeah, write a ticket, I'll just deploy, make it, and it'll be fun. It'll be good. But then developers watches the code, like investigates, and it turns out that there isn't an A in the code, it's a C. And you come to the user and say, hey, there isn't an A, there is a C, and, well, do you still want me to do B? And yeah, usually there's either a panic or you do the B thing anyway. So yeah, and basically what data warehouses are for is to take the data from the source, which kind of is like representing business processes from real life, and make it look more like business processes to improve. But there's one catch. In order to do ETL, to create data warehouses, model it, you need to, first of all, be technically competent in the technology of data warehousing. Firstly, you need to understand the business processes from the real life, how the business runs. And thirdly, you need to understand how it's implemented from the technical point of view. So you have to see the big picture. And the fun thing is, usually in organizations, the ETL guys and data warehouse guys are like a separate team. They create their own magical place where they like model the data and integrate and figure out stuff. And it like, in practice, it turns out very interesting. Yeah, so about ETL, I'm a programmer too, so I have some like programming quotes, which also can be applied to data. So yeah, working on water and developing software from a specification are easy if both are frozen. So it turns out is the same with data. Like when a task, an issue comes to the ETL guy and he needs to integrate like new service, it's cool when you like have specs for the service and you understand kind of what's going on there. But if it's services, continues the development, deployment, then it's like 2 productions a day, schema changes, processes changes, and well, it becomes hell. Yeah, and there is one more thing, Hadoop Big Data, who've used it. It's really fun. This distributed file system and the schemaless idea that you like figure out what's in the data when you read it, not write it, just write it all there. There is one like big problem with that. You still need to understand the data at some point. Like when you're doing classical ETL and data warehouses, you understand it right away because you need it like for integration and cleansing. But with Hadoop, you need it afterwards anyway. And like the same people, maybe more advanced in technology or in business side, will still do this. It just will be like more fancy and well, maybe handle bigger volumes of data. Yeah, and actually this one's fun because there's this article which tells a story how to process things fast without Hadoop, actually using just Linux, like grep, awk, set, that kind of thing, like standard commands. Yeah, so this brings us to like the question what to do, because like we have services, like a standard service architecture is where you have like more than 5 services, and they all interconnect, they all are developed, deployed, and it's like happening right away in business. And you have like an ETL team or Hadoop team anyway, and they need to integrate the data, which is the first problem, and they need to cleanse it like regularly all the time. And if you have like 50 services, what you need 25 people who understand services, like each of them, and the schemas and the business. It's awesome. Yeah, so what went wrong? I actually read some nice books. Ralph Kimball, who read them, who read him. He's like, I consider him a classic in data warehousing. And from the point of view of like from ideas, it's really cool. Like data warehousing consists of really cool and innovative and actually interesting ideas on how to do that. And yeah, one of them is that data warehouses have dimensions, which are basically attributes, and dimensions describe facts. And facts are business process events. What's interesting that this conceptual view turns out to be classical ETL the way we know it. Like we just take the data, we import it, we cleanse it, and yeah, that's it. But if you come to think about this, it turns out that the data that's stored in the services, it's not event data, it's like the residue. It's what happens after or before. And actually what ETL processes are trying to do is to take the residue and recreate the process, which kind of works sometimes. It gives like the most important metrics, because like if you don't have most important reports like profit report, then well, there's no point in data warehouse anyway. So yeah, people do their best. And actually, a few speakers spoke about this in terms of microservices, that the most developed microservices, they actually work with events. They have event buses, or in some other way, they like send events and bring events in. And with if we'd advance the data warehousing model to work with event, it would be really simple. Like there is services architecture. Let's imagine 100 services. They all communicate using events. Like for example, take Kafka. It's even persistent. It's brilliant for data warehousing. And you just take data warehouses as a tool and plug it into a bus. And then you get everything that happens in the service architecture, and it's events. It's like business processes, clean and simple. Yeah, so that's kind of ideas on the first problem. And here's a fun one on the second. So Facebook, 2012, if you are checking code, like committing, you have to maintain your code. And this actually works for data as well. If you created a column, it's your column. And if like it's a bad column, or it doesn't work, or there's no good description, or someone changed the meaning of it, then the people who maintain this thing, they'll fund you. Especially when you present things at conferences. Yeah, so like the usual process of ETL is that you have a team and they integrate with your applications. But actually, there's the problem like of cleansing data, because you need to understand all the things, and the people who actually understand the business processes and the data that was written are the people who like wrote the code, the developers of the services. And what would be, yeah. Thank you. I'll try to make it fast. So yeah, developers who make the services, and this way you don't need to cleanse the data. Like you're a developer, you're developing some feature, and the best way to like work with data is just create already clean data and write it into data warehouses for your needs. So if service developers would own the data, you would already have a clean data in the data warehouse. And first of all, those developers would integrate, and secondly, cleansing would not be like required for at least basic things. So yeah, a little summary. Who puts data in is the primary user and maintainer. We actually tried it in practice. It was fun, and it's it goes faster. It's like an agile way of doing data warehouses. First up, okay. Second, yeah, events are the data. It's like in advanced service architecture, it's like common sense. Yeah, and a little bit, I've got 2 minutes. So technical stuff. You need to pick the right tool for the job. But first up, you need to understand what the job is. Because in an evolving data warehouse, in an evolving service architecture, actually the job, it evolves as well. So yeah, 4 stages of life. This is a true thing. The slide is irony, actually. So yeah, stage 1, mimicry. This very well works with an evolving data warehouse. Mimicry. First stage is when you have monolithic application of service in service architecture and integrated with data warehouse. Data warehouse just copies things. We just copy the data and have access to it and build like basic reports. Second one, when they're like people understand that monolithic application should be split into services and like 5 services come up, then you like just and you have ETL processes and data warehouse. You understand that maybe we could like make some more data, maybe cleanse it a little bit or add some attributes and like change currencies. By the way, I don't know why people do that, but yeah, I've heard that as transformation option. And then more services come up, but usually people don't like can't integrate them all, so they integrate only the main ones. And yeah, and then business people understand they can do even more. Then basically people commit to doing data warehousing the right way, dimensions, facts, and that's basically like the point when people could like take the responsibility of the data for themselves in the services, because like 50 services in the data warehouse is already like too much. And yeah, legacy is a very fun one, because when you work with like terabytes of data, you actually performance is not that of a problem, because like it doesn't make much difference, like 15 minutes or 20 minutes you get the the performance of some query. The main problem is actually the data volumes. And the problem with Hadoop actually is that it's a cool distributed system, but 30 seconds, yes, but it doesn't like work well with volumes. And well, it doesn't perform well. So yeah, for this thing, actually column-oriented databases are the best match, in my opinion, because they compress the data very well. And like when you have a petabyte, you could look up at Amazon how much that will cost a month, and 10 petabytes, that's awesome. Also awesome, yeah. And columnar database would like shrink it in like 10 times, and you'll pay like from the business perspective much less. And that's cool. So yeah, thank you. There's a nice quote: start by doing what's necessary, then what's possible, and then you suddenly will be doing the impossible. Thank you. Here's the Twitter thingy. Thank you.